So now we have the resolution of forces. So resolution is basically known as taking the component of forces into perpendicular directions, right? Into two perpendicular directions, right? So suppose we have this x-axis, this y-axis, and this vector f. Here you can see that I have represented this vector with the bold face letter f, and this vector f is basically making an angle theta with the x-axis, right? So now we want to take the components of this vector f in the x direction and in the y direction, right? That is I cap j cap, in the I cap direction, in the j cap direction, right? So here you can see that to take the component, we have the x component as the fx and the y component as fy, and this is how we represent these components, right? So this fx, this fy, and they will make a triangle, sorry, the rectangle with them, right? So this fx and this is fy. Now we are given an angle theta and we are given the vector f, that is we are already given its magnitude as italic letter f, right? So to find the components, we have this fx will be equal to f cos theta and this fy will be equal to f sin theta. So here you can see that the vector f will be denoted as fx, that is x component I cap, plus fy, that is y component or the component in the y direction, j cap. Alright, so this is the two-dimensional representation of the vector, and the magnitude of the vector f will be equal to italic letter f. This is just the representation and it represents the magnitude. And so the magnitude or the x component or the vector f will be basically f cos theta, and the y component of the vector will be f sin theta. And remember, these components are basically the scalar values, right? Because they are the components along x-axis and y-axis, so we directly know the direction, that is the direction x and direction y. But so uh, that is, we know the directions already, the direction of the components, so we just only need to represent the magnitude, that is the magnitude, the x component magnitude and the y component magnitude. So the x component magnitude in this case will be equal to fx, will be equal to f cos theta, and fy will be equal to f sin theta. So similarly the other case will be, it is pointing to the vector f is pointing towards the origin, right? In this case it was going away from the origin. Now in this case it is pointing towards the origin, right? So in this case the angle is basically equal to theta only in this case also. So in this case the vector will be represented as f is equals to minus fx I cap minus fy j cap, right? So here you can see that the fx is basically the magnitude of the x component, fy is basically the magnitude of f in y direction, right? So it is y component magnitude, it is x component magnitude, so the magnitude will always be positive. So to consider their direction, because they are pointing into the negative direction, negative x direction and negative y direction, we have put a minus sign in here, right? A minus sign in here. So this is how we represent the components of the two vectors, right? So the f vector pointing away from the origin, and f vector towards the origin, right? So this is the representation, f is equals to minus fx I cap and minus fy j cap, right? So fx will be equal to f cos theta and fy will be equal to f sin theta. Here they should be positive because we don't have any concept of component, the magnitude of the components being negative, right? The other thing you can say that either you make these as negatives or these as negatives. So we have already made these signs as negative, so that is where we are taking this as positive, right? So fx will be equal to f cos theta and fy will be equal to f sin theta only. So this is how we take the components of a given vector along the two perpendicular directions. Now suppose if you want to find this case, right? So we have a wedge, right? A wedge B. This is wedge. Let name them. So this is a wedge B wedge. So this is wedge B, and this is wedge. This is a block A placed on top of wedge B, right? And the angle of wedge B is basically beta, and a force is acting on this block with an angle alpha to the plane of the wedge, right? So the surface of wedge, this angle alpha basically makes an angle alpha. This force F basically makes an angle alpha with the surface of the wedge. So this is how the representation in the problems will be given, right? So now we want to take the components of this force along this surface and perpendicular to this surface. That is, here we are assuming the x and y axis to be as this, right? So y axis will be perpendicular to the surface of the wedge, and y x axis will be along the surface of the wedge, right? So x-axis is along the surface of the wedge and y-axis is perpendicular to the surface of the wedge. So now we want to make the components of this force along this x-axis and along this y-axis. Then what we will have is this will be equal to f cos alpha and f sin alpha as the components, right? So this is basically f cos alpha and f sin alpha. Now this is one type of taking the components, right? The other type of components we can take here is we can assume the x and y axis to be equal to be on these sides, right? So x-axis will be as general case we have, as generally we assume, that is this will be y-axis and this will be x-axis. In that case, if you want to take the components, then we have to do it like this way, right? So this is y-axis, this is x-axis. So in this case, the total angle this force will be making with the x-axis will be this angle beta plus alpha, right? So you can see that this surface of the wedge is already making an angle beta with the horizontal, right? So the total angle this force will be making with the horizontal will be equal to alpha plus beta, right? So this alpha plus beta is making an is the angle between the force and the horizontal. So we have the x component in this case, that is the x component in this case will be equal to f cos alpha plus beta, that is the total angle, and the f sine alpha plus beta, right? So this is the angle now, this is the angle now, and we are taking the components along this side and this side. So this is how we take the resolution of the two component of the we take the component of the force along any given surface or perpendicular to any given surface, right? So this is how we take the perpendicular and parallel component of the given force. Now let's see one example to understand these two concepts, right? So previously we have seen the addition formula for a given for addition formula for the addition of two vectors, and this is that can be used for calculating the total effect for any given number of forces. And this type of approach can also be used for solving the problem, right? So we will see one problem. In that problem we will use two methods to solve the problem. Okay, so let's see that problem. So we have one problem here, and the problem says that if we are given two forces, that is one greater force which is of 100 Newton and one smaller force, and they are acting at an angle of 120 degree, and the condition given to us is that the resultant is perpendicular to the smaller force, then we need to find the magnitude of the smaller force, right? So before moving on, we need to first visualize this problem, right? So we need to draw this picture, and the picture says that the smaller force is S, and the resultant is making an angle of 90 degree with this smaller force, and the larger force, that is of 100 newton, is making an angle of 120 degree with the smaller force. Right, so this gives us the clear picture of the total problem. Right, so we are given the condition here that the resultant is making an angle of 90 degree with the smaller force, but we have seen, when we have seen the uh, addition of two vectors, that is, if resultant is making an angle of alpha with the vector a, then the formula says that tan of alpha will be equal to b sine theta upon a plus b cos theta. Right, so let's apply this formula here. So a will be replaced by s, b will be replaced by 100 newton, alpha will be replaced by 90 degree, because the resultant is making an angle of 90 degree here, and theta will be replaced by 120 degree. Theta is basically the angle between the two vectors which needs to be added. So here we are adding the vector s and vector 100, the force s and the force of 100 newton, and the angle between the two forces is basically 120 degree. So we are having a clear picture as this: tan of 90 will be equal to 100 sine of 120 degree upon s plus 100 cos of 120 degree equal to infinity. Right, so this infinity we can write it as equal to 1 upon 0. Right, so we can see that s plus 100 into cos of 120 is equals to 0. So this will give us s plus 100 cos of 120 equal to 0, and then we take this to the other side. So this will become s equal to minus of 100 into cos of 120 degree, and cos of 120 degree is basically minus of 1 by 2. So when we solve this, we will get s equal to 50 newton. Right, so the formula says, so we get the answer as s equal to 50 Newton. This writing and here is very necessary, because otherwise we don't know what the quantity is. Right, so whenever we are dealing with the forces or vectors, we need to write their units. Right, so be sure to write the unit in the examination, otherwise they will give you some something like this, that is, they will give you some options like a equal to 100. Right, a equal to 100, b equal to 20, c equal to 40, and d equal to 50. Right, so if they give in the question that you need to find the smaller force in newtons, right, they will give you in the question, find the magnitude of the smaller force in newtons, then they will give you answer options like these. Right, so if they ask in the question, find the smaller force in newtons, then you need to then they will give you the options like this: 120, 40, 50. Then you will tick simply on the 50, but they don't give you in the question that you need to find the smaller force, and then they will not give you what uh, unit you need to find it in. Then we will have what, we will have problem there. Right, because we don't know in what units we need to find. We can find it in the kg force unit also, we can find it in newton units also, we can also find it in the cgs system of units also. So that will create a problem. Right, so this is that is why we need to be sure of the units in the problems. Right, so here you need to write s is equals to 50 newtons. So this is the first method of solving the problem. Now we will see the second method for solving the problem. Right, so the second in the second method, what we will use, we will take the components of this 100 newton along this perpendicular line and this line. Right, so the new you can see that the total angle is of 120 degree. Right, so since the total angle is 120 degree and this angle is 90 degree, so the angle remaining, the remaining angle, the with the resultant, this 100 newton will make is 30 degree. Right, so this 100 newton will make angle of 30 degree with the resultant, right? So we have taken the components of this 100 Newton along the perpendicular direction and the parallel direction, right? So this 100, this will be equal to 100 cos 30 and this will be equal to 100 sin 30, right? So this 100 cos 30 will be equal to what? 100 into root 50, root 3 by 2, right? So cos 30 we know that is equal to root 3 by 2, so this will give us 100 into root 3 by 2, so this will be equal to 50 root 3, and this will be equal to 100 into sin 30, so this will be equal to 100 into sine of that sine 30 will be equal to 1 by 2, so 100 into 1 by 2 will be equal to 50. So here we are having this 100 into sine 30 is equal to 50, right? And this will be equal to 50 root 3, right? So this is basically 50 root 3, right? And we have just uh, cut it down this force, right? So this original force is now is not now in the problem, right? We have just got rid of this total force, and we have taken the component of the this force into the perpendicular and the parallel direction. Now you can see we are having three forces in our consideration, that is this smaller force, this 50 Newton force, and this 50 root 3 Newton force, right? So this and we are given the condition that the resultant is perpendicular to the smaller force. So the smaller force needs to be equal to this 50 Newton, so as they can cancel out each other. This force should cancel this force. Then the resultant force will be remaining. We will be remaining with the 100 cos 30 will be equal to 50 root 3 Newton force, and since this will be remaining only, so they will get cancelled out. So from this condition we can say that 100 sine 30 degree should be equal to this is equal to 50, and this should be equal to S, right? That is smaller force, that is the unit of or the magnitude of the smaller force, right? So this is how we can easily solve the problems, and hence finally we have S equal to 50 Newton. So we have just used two methods, that is method 1 and that is method 2. So here you can see that we didn't think anything, we didn't got any idea about the problem, but we have just used the formula, right? We have just used the formula and we have got the answer as equal to 50, and here we are actually using our mind to visualize the problem more intuitively, right? And then we are applying we are just getting an idea from the visualization that this force should be equal to this force, so as to get the resultant should be equal to perpendicular, right? So this second method is not having too much to write, but too much to visualize, and this first formula or the first method is not giving us a clear picture, but we are using the formulas only. So here we can see that how important it is to visualize the problem, because in the examination if you visualize the problem we can easily see that the answer is 50 and we don't need to write much in the examination. So my job is to make you visualize the problems, right? So if I will be able to visualize the problems to you, then you will be able to understand the problem very easily and do it in very less time, right? So in very much few time or very less time in the examination. So this is the idea behind the problems, and this is how you should be able to do the problems in the examination. So this is all guys for this lecture. See you in the next lecture.